The player can now pose their hands, climb on walls, and grab objects. But let's polish the code and add a couple of small features for our game. So, the VR local script controls the camera's rotation even when we don't need it to. To change this, go to the VR local script and add in this code. Now, let's test our changes. When we tilt the right thumbstick left or right, our camera will instantly rotate thanks to Roblox's built-in camera turning feature. This is good because we won't have to turn 180 degrees in real life. For our next function, so our grabbed objects don't get lost on the floor, let's make them respawn after being grabbed. In the player module script, set up these two tables. Next, when we grab a part, we'll store this part in the respawning objects table. Then, when we let go of the part, set its grabbed boolean to false. We'll use the respawn objects table to detect whether or not a part has been grabbed. Next, make a function to respawn a grabbable part. When a part respawns, make sure the network owner of the respawn part is nil so the server can be the owner. Now, in order to make a respawn timer, we're going to need a run service. With it, we can create a heartbeat timer when we let go of the grabbed part. To avoid lag, disconnect the respawning heartbeats after the grabbed part respawns. Let's test our changes using the VR emulator. Let's throw our cube to start the timer. Now, wait for 10 seconds. As you can see, the cube respawned and we can grab it again to start the timer once more. The timer will also restart if we grab and let go of the cube again. Let's exit test mode now. So, since this will be a multiplayer game, we're going to add codes to prevent other players from grabbing parts that are already grabbed by another player. Close the emulators, and in the grab script, when a part is grabbed, we'll create a string value to know which player is grabbing the part. And when we let go of the part, we'll destroy the string value. Now, in the VR local script, we'll make an if statement to check if the string value exists or not, and if its value has our player's user ID. Now that we have added a big feature to our grab function, let's move on to a different one. Our player currently has no collision, but why? So if we were to use the humanoid root part to collide with the game as usual, it would fix this problem. But if we were to change the camera's position using the VR headset, the humanoid root part would not move with the camera. To fix this problem, we're going to make a workaround. First, we will create a part. Next, weld it to the original humanoid root part. We can then get the camera's X and Z position and convert it into a position relative to the humanoid root part. Now, apply that position to the C-frame 0 property of the weld so that the part can move with the camera and character. That's how we will make the character collide with parts accurately. Let's make this work. Before we attach the torso, create the part and the weld. But for the C-frame 1 property, we'll position the collide-able HRP to the camera. Now, in the VR render step, use the toObjectSpace function and give the camera render C-frame's X and Z position as the main argument. Our player can now collide with parts. We can collide with parts while we're climbing too, but it will make climbing awkward. So, let's remove the collision when the player starts to climb. In order to collide with parts again, once the player has stopped climbing, turn the collide-able HRP's collision back on. Before we test, let's make our real humanoid root part have no collision. Now, let's test our changes. When we try to bump into the wall, it stops us from phasing through it. And when we try to move by controlling the VR camera, it still won't let us phase through the wall. But while testing, as you saw, the character has no skin, which does not align with our hands. So we'll use our avatar's design for our torso using code. In the server script, add in this code. The code will load our avatar's items and apply it to the dummy character. Let's test this change now. Now, when you look down, you'll notice that the torso is my avatar's torso. The thing is, if you look closely, you'll see this line. This is actually my avatar's face accessory. This accessory should not be seen by the player. Let's fix this first. In the VR local script, above the onCharacter added function, create a list of accessory types that we will remove from our player. For my list, I'm going to focus on head accessories. Next, at the end of the onCharacter added function, create a for loop to iterate through each child of the dummy character, destroying them if they are accessories and their accessory type matches any in the list. Let's also destroy the face to ensure our camera cannot be blocked by our character. Let's test our changes. As you can see, that line is gone. But there is still one problem. My avatar's trench coat is posed awkwardly. I'm going to fix this by making jackets unable to load in our game. In the starter player's properties, scroll down until you find Load Character Layered Clothing. Select Disable to prevent our avatar to load its jacket when it spawns. Finally, let's test our changes again. Now that the jacket is gone, the way we see our character is not awkward now. Next, let's move on to another function. So, when we go to the server view, you can see that our hands are nowhere to be seen. Let's fix this. Close the emulators and enter the server script. In it, create a new function. Let's add more code to it. Similar to how we made the torso correctly update in the server, make the server hand follow the hand mesh, which will be our real hand, by setting attachment 1 to the hand attachment. We'll also make the server hand copy the rotation of the hand mesh using the align orientation object. Make the server hand not collide with parts and then return it. Next, in the character added event, after destroying the neck, use the create server hand function. But since we will be duplicating our hands, the server hands will be visible to the player too. To fix this, go to the VR local script and, at the end of the onCharacter added function, set the server hands transparency to 1. Let's test our changes. Now, when we move our hands, and then we switch to the server view, you can see the hands aligning with our hands in the client view. If we move with our character, the hands, torso, and the head align with the client view too. Let's move on to another function. In the VR render step, change the VR camera position to be the Get Render C frames position. So, it could be hard to tell when our hand is actually grabbing or climbing. To avoid confusion, let's highlight and play a sound when the hand starts to grab or climb. For the sound, we will have to get and add it in the game. In the replicated storage, create an assets folder, and inside of it, create a sounds folder. Then, I'll paste my grab sound that we'll use. These are its properties. Now, let's get back to coding. Under the add highlight function, create another function called play hand sound. Let's now use the new functions we created. In the onHand climb function, call the two functions at the same time. So whenever we climb, our hand will be highlighted in yellow and a sound will play. Let's do the same for the grabbing. Lastly, when the player's hands open, destroy the highlight created by the add highlight function. Let's test our changes. Now, when we try to grab our cube, the hand sound plays and the hand grabbing the cube is highlighted yellow. When we climb, the hand that is climbing also plays the hand sound and is outlined. Let's exit test mode. So, in the VR local script, this code is a for loop. So, it might grab or climb on multiple objects if they are near to each other, which our code does not handle. To fix this, break the loop if the code has found something to climb or grab on. For our next function, we'll make our character transparent whenever the player is in the air or is climbing, so it's easier to see the ground if the player needs to look down. To add this function, insert this code. The isPerma invisible Boolean value is there just in case we don't want a specific object to be semi-transparent. Under the function, create another function to use the setPart invisibility function for each child of the character. Now, in the onCharacterAdded, reference the humanoid and check if the floor material is air. We'll avoid turning the character semi-transparent if it's climbing since we are going to have a separate code for that. Next, in the onHand climb function, when the player starts to climb, make the character semi-transparent. We'll do the same when the character stops climbing. Now, when we go to test mode, when you jump, you should see that the character becomes semi-transparent like a ghost. The same happens when we climb. And when we let go, the player's transparency goes back to normal. We're almost done. Let's just add a few more codes. In the VR local script, we will not execute the grabbing code if the hand is already grabbing something. Next, we'll add code to handle whenever the player resets. We should do this in the server script. To use this function, we'll connect it when the player resets or when they leave the game. Also, in the VR local script, when the player resets, disconnect the VR render step so it does not run while our player is dead. Lastly, in the onHand let go function, reset the previous movement vector after it is applied. And we're done. Now that we have all our mechanics ready and polished, we can move on and add decorations, objects, and obstacles for our player to climb on. But for me, I'll use a map I've created just for this game.